Hello and welcome to Unit 2, the Land of Probability. Today what we're going to be doing is just reviewing some of the probability that you went over in grade 8. So don't panic too much. You'll have plenty of time for it to get much harder later on. So probability is the likelihood or chance of an event occurring. This is a formula that you would have been used to in grade 8. So the probability of an event occurring is equal to the number of outcomes the event has divided by the number of outcomes in the sample space, which means the total number of outcomes. So for instance, if you were trying to find the probability of drawing a queen from a deck of cards, the number of outcomes of a queen is 4, and the total number of outcomes in a deck of cards is 52, so that would be equal to 4 over 52. You'll see some examples later on as we go. There are 3 types of probability. The first type is theoretical probability, which is just what we have up here, the likelihood or chance of a given event occurring. So this one is theoretical probability. The second one is experimental, or also called empirical probability, which is calculated based on how often the event occurred after collecting data or running an experiment. The third, subjective probability, is an estimate of the likelihood of an event based on intuition and experiences, which is an educated guess. So basically the 3 types of probability are: experimental is what actually happens in an experiment. So what's the probability of something happening when you're running an experiment? Theoretical probability is the probability that should happen in a perfect world. And subjective probability is any kind of probability where you are making an educated guess. So when they're predicting the probability that the chance of rain is 30%, that's a subjective probability because they're actually doing some research and they're not just pulling a number out of the air, but they have some education behind their guess. So here is a very basic example. Billy Bob rolls a die and records the number of times or the number of dots shown on each roll. After 100 rolls, he counts that 22 of them resulted in a roll of 4. Whenever you get a probability question, the very first thing you need to consider is what the favorable event is. So we have what we call our let statement. So because we're rolling a 4, we're just going to use the letter F to represent rolling a 4. Now, the theoretical probability is what should happen. So the probability, P for probability, of inside the brackets is the favorable event, so rolling a 4. So that's the probability of rolling a 4 is. On the bottom is, if you remember the formula, the number of outcomes in the sample space, the total number of outcomes. So there are 6 total outcomes in rolling a die. And in the top, the number of outcomes that the event has. So that's the number of favorable outcomes. So there are 6 total outcomes, and one of them is favorable. So 6 outcomes, 1, 2, 3, 4, 5, 6, and only one of them is a 4. Probabilities you can leave as a fraction in lowest terms, or, if you're going to round it to a decimal place using the approximately equal to symbol, you can round it to a decimal, to 3 decimal places, or you can round it to a percent to 1 decimal place. Either one, but if you round it, you should use your approximately equal to symbol. Experimental probability, what actually happens in an experiment. So in this case, the probability of rolling a 4 is the number of favorable outcomes. So we rolled the 4 22 times. So that is your NF. And out of 100 times. So that is your NS. So it's 22 out of 100. So again, a fraction in lowest terms or a decimal. This time it's not rounded, so you don't need the approximately symbol, or a percent. So there's your most basic example, just making sure you're making note that you have to make a let statement. Your probabilities always have to start with the probability of the event, and your answer is a fraction either in lowest terms or a decimal. If it's rounded, you need your approximately equal to symbol. So just some information about probability, just to remind you from grade 8. A probability of an impossible event is 0. So that would be like rolling a 7 on a 6-sided die. The probability of an event being certain is 1. So for instance, if you were drawing a card from a deck of cards, what's the probability that you would draw either a spade, heart, club, or diamond? Well, that's 1 because it has to be one of those. There's no way of it being anything else. So the probability ranges from 0 to 1. Now this may seem obvious, but many times when you get into some harder probability questions, people get answers where the probability is 1.35 or something like that, and people don't pick up on the fact that that has to be wrong because you can't have anything bigger than 1 or less than 0. So the probability of an event not occurring has this type of notation. So you can have an apostrophe to represent an event not occurring. More commonly, which we'll use in this class, is a line over top. Some people also write it with a slash before the E. Oh, I already wrote that one. So this should actually be. So if that's not written in your course pack, just make that change. That should say line over top. So the probability of an event not occurring is 1 minus the probability of an event occurring. So from our previous example, the probability of rolling a 4 was 1 over 6. So the probability of not rolling a 4 is 1 minus 1 over 6, which is 5 over 6. So that's the way that works. So some definitions that you'll need to know. Anytime we talk about a fair or an unbiased or an unweighted object, it means that each result has an equal chance of winning. An unfair or a biased or a weighted example would be one or more result has a higher chance of winning. So if you were to roll a die or flip a coin, the results are always equal. So anything you roll has a probability of 1 over 6. Anything you flip has a probability of 1 over 2. But if you had a bag of marbles with 6 red and 8 white, because there's more white, the probability of getting a red is 6 over 14, and the probability of getting a white is 8 over 14. So since the probability of getting a white is higher than the probability of getting a red, then that is considered an unfair outcome. Single outcomes and compound or single events and compound events is pretty simple. Single events is just when you do one thing. So you draw one card, you choose one person, you roll a die once. A compound event is when you do more than one thing. So if you draw two cards, if you flip two coins, if you choose four people, etc. So those are some definitions. What we're going to do is just do a couple of examples to get your feet wet. And today's work isn't going to be much different than just the questions you did in grade 8. So tree diagrams are useful for determining the sample space, and that's especially anytime you have an AND situation. So in this example, the 4 aces are removed from a deck of cards, a coin is tossed, and one of the aces is chosen. What is the probability of getting heads on the coin and the ace of hearts? Draw a tree diagram to illustrate the sample space. Before you do any work, you always have to define your two events. So we're going to let H represent flipping a head. And we're going to let A represent drawing an ace of hearts. When making the tree diagram, the first set of branches is going to represent the outcomes of the first event. So the first thing that we're going to be doing is flipping the coin. So there are two possible outcomes. We could get a head or we could get a tail. So the first set of branches represents the number of outcomes in the first event that you are doing. The second set of branches represents the number of outcomes in the second event that you are doing, which is drawing an ace. So there are 4 outcomes for each of these. You can get a heart, a diamond, a spade, and a club. Now, because the probability of a heart is equal to the probability of a head and a tail, and because the probability of each of these is the same, that means when we go to look at the probability of getting a head and an ace, we can just count that there are 1, 2, 3, 4, 5, 6, 7, 8 branches. That only works if the probabilities are equal on both sides. You'll see later on what happens if they're not, but for now, you can just count the branches if the probabilities are always equal. Now, out of those 8 branches, which one is favorable to flipping a head and drawing a heart? And that would be this branch right here, a head and a heart. So that means we have one favorable branch out of the 8. So therefore, the probability of flipping a head and drawing an ace of hearts is 1/8. Now I know that becomes a lot of writing and that would take up a lot of time on the test, so it's okay if you just want to say, therefore, the probability is 1/8. And just remember when making the tree diagram, the first set of branches here would represent the coin. That is the first action, is flipping the coin. There are two outcomes. The second action is rolling the die, and there are four outcomes for each. The next type of example you're going to see are examples that involve rolling two dice. When you roll two dice, a chart can be useful for determining the sample space. So this is what we call the dice chart. So these numbers here, 1, 2, 3, 4, 5, 6, this represents rolling die 1. And these numbers down here, 1, 2, 3, 4, 5, 6, represent rolling die 2. And all of the numbers in the middle represent the sum of the two dice. So for instance, this 5, you rolled a 2 on the first die and a 3 on the second die. So that's where you got a sum of 5. So all the numbers in the middle are the sums of the two dice. So that's the way a dice chart works. So in this example, two dice are rolled. What is the probability that the sum of the dots is an even number less than 8? So E is going to represent an even number less than 8. And if you even want to shorten your work, rather than saying less than 8, you can just use the less than symbol, like that. So we need the probability of having an even number less than 8. So because you have 6 outcomes on the first die and 6 outcomes on the second die, the number of outcomes in total are 6 times 6, which is 36. So when rolling two dice, there are always 36 outcomes. And to count how many of these are favorable, we're looking at how many are even and less than 8. So that's the 2, the 4s, and the 6s. Less than 8 does not include 8. So that is 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's 9 out of 36. And in lowest terms, 1/4. So therefore, the probability is 1/4. And that's about it for your introductory lesson to probability. If there's anything that you didn't understand, make note of it and ask your teacher during the next class. Thank you.